All right, this video is the part 1 of section 1.3, and we're going to start discussing the trig functions. So here we have section 1.3. When we look at the x and y axes here, so let's say we have this angle theta, okay. So, and I can form a right triangle here. This is my x value and the y value, and of course this is r, and we are going to focus on right triangles here. And I just want you to know that this y, or this side, is called the opposite side, and as you see, it's opposite to the angle theta, and the x is called the adjacent, and as you see, it's adjacent to the angle theta, and of course r is the hypotenuse of this right triangle. And as you know from applying the Pythagorean theorem, r equals, or r squared equals x squared plus y squared. And now we're going to introduce the 6 trig functions: the sine, cosine, tangent, cosecant, secant, and cotangent. First, the sine theta is the opposite over the hypotenuse. So you can look at it this way. Sine is the opposite over the hypotenuse, which is y over r. Cosine theta, my second trig function, is the adjacent over the hypotenuse, and you can think of it this way: the cosine is the adjacent over the hypotenuse. Next, we have the tangent function theta, and it is the opposite over the adjacent side. So it's y over x. And we can look at it this way: tangent theta is the opposite over adjacent. Next, we look at the cosecant function of theta, and it is the reciprocal of the sine function. So it is the hypotenuse r over y, the opposite side. Next, we have the secant function, secant of theta, and secant is the reciprocal of the cosecant function. So it's the r over x. And lastly, we have the cotangent function, cotangent theta, and it is the reciprocal of the tangent theta. So it's x over y. And these are our 6 trig functions. So let's look at an example to see how to deal with these functions. So here is my first example, and it says find all trig functions that go through eight 15. So I know this is my x value and this is the y value. I'm going to graph it here. And I know that x is 8 and y is 15. And again, I can form this right triangle. So this is 15 and here is theta. In order to be able to find the 6 trig functions, I'll need to find the hypotenuse here. And as we said earlier, I can find that by applying the Pythagorean theorem. So r squared equals 8 squared plus 15 squared. And that's actually equals to 64 plus 225. And that would be r squared equals 289. Take square root for both sides. Will give you r equals 17. So now I know my hypotenuse is 17 to be able to calculate my trig functions. So first we're going to start with finding the sine theta. And as we said earlier, it's the opposite over the hypotenuse. So it's 15 over 17. Next, we'll find cosine theta. And we know it's the adjacent over the hypotenuse. Here is the adjacent side for theta. And this is the hypotenuse, so it's 8 over 17. Tangent theta is the opposite over the adjacent. So it's 15 divided by 8. Next, we will find the cosecant of theta. And we said it's the reciprocal of the sine function, or you can look at it as it's the hypotenuse over the opposite. So it's 17 over 15. And we'll also find secant theta, and it's the reciprocal of the cosine. So it's 17 divided by 8. And again, we'll find the cotangent. That's the last one. And it's the reciprocal of tangent. So it's 8 over 15. And these are our 6 trig functions. Next, we will look at another example. This time, they're telling us my x and y value is -3, 4, and they are giving us the hypotenuse, which it is r equals 5. So I'm already given the hypotenuse here. But notice this time x is negative. So when we graph it, we're going to go to the negative side of the x-axis. Okay, so here is my x value, -3, and y. Here. Again, I can form a right triangle. This is 4, and here is theta. This is theta. So here's my triangle. I'll simply find, so this time we know the hypotenuse is 5. We don't need to find it. Sine theta is the opposite over the hypotenuse. So it's 4/5. Cosine theta is the adjacent side over the hypotenuse, so it's -3/5. Notice the cosine is negative this time. Then we have tangent theta. And that will be 4/3. Cosecant theta we said cosecant is the reciprocal of the sine, so it will be 5/4. Secant theta is the reciprocal of the cosine, so it's 5/3, or yeah, 5. So it's -5/3. And cotangent theta, which is the reciprocal of the tangent function, that is -3/4. And that's it. These are the 6 functions. So you can, a way to memorize the sine, cosine, and tangent is to look at these as so, waka, towards. The sine is opposite over hypotenuse, and the cosine is the adjacent over hypotenuse, and tangent is the opposite over adjacent. Next, we're going to look at another example. And we are still in section 1-3. Let's continue. We have -2, 0, and r is 2. So again, a quick sketch here on the side. This is -2 and 0. The sine, so sine theta is, we said it's the y value over the hypotenuse, but the y, it's 0, so it's 0/2. This is 2, 1, 2, which it is 0. Cosine theta is the x over the hypotenuse, and it's -2/2. and it's -1. Tangent theta will be the y value over the x value, so that's 0 over -2, and it's 0 in this case. Then we look at the cosecant of theta, and we said it's the reciprocal of the sine function, so it's 2 over 0, and for sure this is undefined because we cannot divide by 0. The secant theta is reciprocal of the cosine, so that will be 2 over -2, and again that will give me -1. And cotangent theta, it's the reciprocal of the tangent, so that's -2 over 0, and again we cannot divide by 0, so it's undefined. Another example, we have 4 -4 with r of 4√2. Again, a quick sketch here on the side. So we see that we have 4, x is 4, but the y value is negative this time, so we're going in the negative direction here. And here is theta. So here is my right triangle. This is theta. I know that this is -4, and I've been told that r is 4√2. And again, we are asked to find the 6 trig functions. So we'll start with the sine. Sine theta is the opposite over the hypotenuse, which is -4 over 4√2. But because we don't want to have a root in the denominator, so I am going to multiply the top and the bottom by √2. And that will give me -4√2 divided by 4 times 2. And this could be reduced to -√2 over 2 if you cancel the 4 on the top and the bottom. Next, we'll look at the cosine. And that will be 4 over the hypotenuse, which it is 4√2, and we'll do the same thing here. But we can reduce it first, right? That's 4 can cancel out from both top and bottom. So this is 1 over √2. Now we can multiply by √2 over √2. And that is √2 over √2 times √2, that's 2. This is my cosine theta. Tangent theta is y value over the x, which is -4 over 4, and that's a -1. To find the cosecant, we said it's the reciprocal of the sine function. I'll do it here. Cosecant theta is, it's just the reciprocal for the sine. So that's root 2 over negative 1, and it is negative root 2. Secant theta is the reciprocal for the cosine, so it is root 2 over 1, which it is root 2. Then we have the cotangent theta, that's the reciprocal of the tangent, which it will be the same, negative 1. Okay, last thing to mention in this video is that when we have our x and y axes like this, it's giving us 4 quadrants. This is quadrant 1, this is quadrant 2, quadrant 3, and quadrant 4. And as you see in quadrant 1, both the x value and the y value are positive. So x is positive because we're going in the positive direction of the x-axis, and y is positive as well. And so all 6 trig functions in this quadrant, when theta is in this quadrant, all 6 functions are positive. So I'm going to say all 6 trig functions are positive. In quadrant 2, as you see, x is negative while y is positive. And when theta is in this quadrant, I'll have the sine function and the cosecant to be positive. The rest of the functions are negative. In quadrant 3, we have x is still negative, y is negative as well. So in this quadrant, I have the tangent this time and the cotangent function to be positive. The rest of the functions are negative. And in quadrant 4, we have x is positive while y is negative. And when theta is in this quadrant, we will have the cosine function and the secant function to be positive, while the rest are negative. Okay, that's it for this video. That's part 1 of section 1.3. I'll see you later.